Good day once again, grade 10s. I hope you're all still safe at home and all still enjoying your extended holiday. But I'm sure all of you, at least some part of you, actually want to go back to school at this point, even if it is just to get out of the house. I'm sure that feeling will only last for about a week. But we are at home and we have to continue working, so I'm making another video for you guys. And I'm going to try and make this one a bit shorter because I know the previous one was way too long. So I cut out all of the unnecessary slides that is straightforward, and I included some animations that is going to allow me to explain the work, and you can just write down the notes that doesn't need any explaining. So don't use this video to make your notes. You still have to use the normal PowerPoint for that. But this one will explain the vital processes in a bit more detail, and also give you some visual information of how this works. And this work is very important to understand. If you understand it, it's a lot easier to remember it. So pay attention and make sure you understand the work. That is the purpose of this video. Okay, so let's jump into it. So firstly, what is transpiration? Well, transpiration is the removal of water vapor from the aerial parts of the plant. The aerial parts is the stems and the leaves. So basically the part of the plant that is outside of the ground. So the removal of water, how does this removal take place? Or how does it happen? Through evaporation. So we're going to look exactly at this process in a second, but you need to understand, or you need to know the definition: the removal of water vapor from the aerial parts of the plant. So a question that I usually ask in the beginning of this chapter is, why do plants need water? And there's a bunch of answers like growth and to live, which isn't wrong entirely, but it's actually not the main purpose of water, or not, at least not what most of the water is used for. And then usually people say photosynthesis, but this is also not 100% true, as only about 2% of the water is used for photosynthesis. So the rest of the water actually just evaporates out of the plant, and most of that is through the stomata. Some of it is through the cuticle. So if you remember the cuticle, it's a waxy layer that prevents water from evaporating, but some of it still makes its way through the cuticle, and so about 10% of the water evaporates through the cuticle, but most of it through the stomata. So that's what we're going to look at today, and that process of evaporation is transpiration. Okay, so here's the process of transpiration. I'm not going to go through all of this, as I'm going to explain it on the next slide, but you need to know this process. You need to be able to write down this process, but I'm rather going to explain it to you through some animations on the next slide. Okay, so here we have a cross section of the leaf, and we zoomed in here on the edge of the leaf. So here we have a xylem vessel bringing some water. Here we have spongy mesophyll, and over here we have the epidermis. So water is taken up by the roots and then taken to the xylem, and then the xylem takes that water all through the plant. So this xylem vessel over here is transporting water, but a lot of that water, or some of that water, is going to make its way into the spongy mesophyll. So it's going to be taken up by the spongy mesophyll, and in fact so much water is going to get taken up by the spongy mesophyll that it becomes saturated with water. And this is going to cause some of that water to evaporate into the spaces, the open spaces here, called the intercellular spaces. And now that a lot of the water is evaporated into the spaces, it causes a high concentration of water inside of the leaf, and a lower concentration outside of the leaf. And if you have a high concentration of something in one area and a low concentration in another area, this causes a diffusion gradient. And if there's a diffusion gradient and an open space, like we have here with the stomata, then that is going to allow the substance to move from the high concentration, area of high concentration to the area of lower concentration. And that is how water moves out of the leaf. Okay, so quickly let's just recap. So you'll see that it's quite simple. Water arrives via the xylem, then is transported to the spongy mesophyll, then evaporates into the intercellular spaces, and this causes a high concentration of water inside of the leaf, a low concentration of water outside of the leaf, which results in a diffusion gradient, and then allows water to evaporate or diffuse out of the plant via the stomata. Okay, simple as that. So we're going to move on to the rate of transpiration and look at factors that affect transpiration. So firstly, just quickly, the rate of transpiration is basically just the rate at which water evaporates from the plant. Okay, so quite simple, but it's important for the next couple of aspects that we are going to look at. And then also just briefly, I need to mention that the rate of transpiration is measured with a potometer. In your notes, you have to paste in the potometer, and we also go a bit more in depth in the potometer, but for this video I'm just going to skip over it as we just want to look at the factors. So the factors that affect transpiration is wind, humidity, temperature, light intensity, and altitude. So we're first going to look at wind. So before we can understand how wind affects transpiration, let's just quickly look at what happens when transpiration takes place. So the water moves out of the plant, but if there's no reason for them, they're not really going to go anywhere else, especially because water likes to cling to other surfaces, other things. So they're just going to stay there around the leaf, and this is going to increase the concentration of water outside of the leaf. And if the concentration outside is similar to the concentration inside, then that reduces the diffusion gradient. So now that force that was driving the water out of the leaf isn't as strong anymore. So the rate of transpiration is going to decrease. So how does wind come into all of this? Well, if the wind starts blowing, it is going to blow away the water vapor on the outside of the leaf, increasing the diffusion gradient again, and increasing the rate of transpiration again. So as soon as water evaporates out, it is just going to get blown away by the wind. So let's look at how this looks on a graph. So if we plot a graph and we put the wind speed on the x-axis as the independent variable, and the rate of transpiration on the y-axis as the dependent variable, then we can look at what's going to happen if the wind speed increases. What is going to happen to the rate of transpiration? So in the beginning, you're going to see a sharp increase in the rate of transpiration, but that is very soon going to slow down. That increase is going to slow down because the wind can only blow away a certain amount of water vapor. If there is no more water, then it's not really going to affect the rate of transpiration. And eventually, the rate of transpiration is going to plateau. So it doesn't matter how much the wind increases, it is only going to increase the rate of transpiration up to a certain point, and then no further. So we explain this graph as increasing sharply, and then the increase slows down, and then it plateaus. Okay, so that's the first factor, wind speed. Let's look at the next factor. The next factor we're going to look at is humidity. Humidity is the amount of water vapor in the atmosphere. So you would see this sometimes on the news and the weather, where they give you the humidity. So if it's very humid outside, then it feels stuffy. It makes it difficult for your sweat to evaporate off your skin, and it makes it feel warmer than it actually is. So this is because the amount of water in the air doesn't allow for the evaporation to take place. So the similar thing happens in plants. If there's a lot of water vapor in the air, then the water can't get out of the plant. So let's see how this looks like. So when the water outside of the plant increases, then the difference in concentration means that the diffusion gradient decreases. So now all of a sudden you have a similar concentration outside than you have inside of the plant, which means the diffusion gradient is significantly smaller, which slows down the rate of transpiration. So let's go a bit slower through this and see how this looks like on a graph. So if we have again the humidity on the x-axis and the rate of transpiration on the y-axis, we're going to look at what happens to the rate of transpiration as the humidity increases. So we're going to start off quite high because now there's no water vapor in the air, so the rate of transpiration is going to be very high. So we're going to start off high, but then we start to decrease. So as the amount of water vapor in the air increases, the rate of transpiration decreases. And if we continue, you'll see that it just continues down a straight line. So as the water droplets in the air increase, the rate of transpiration decreases. So you're left with a graph showing that as humidity increases, the rate of transpiration decreases linearly. Okay, meaning it's a straight line. Okay, and that is it for humidity. Let's go to the next one. The next factor is temperature. Now, again, for temperature, we need to understand some principles before we can explore the effect of temperature. So from grade 8, you would remember that all particles have kinetic energy, and temperature increases the kinetic energy of particles. So at a low temperature, the particles are going to move quite slowly, and this means they don't bump into each other as much, and the pressure is relatively low. But if you increase the pressure, or if you increase the temperature, you are going to increase the kinetic energy, which means they bump against each other more, which means the pressure increases. And if the pressure increases, the diffusion gradient increases. And if the diffusion gradient increases, it means more water is going to escape out of the plant. So it's basically like having a balloon. The more you blow up the balloon, the greater the pressure inside of the balloon, and if you let go of the balloon, the faster that air will rush out of the balloon. So the same thing happens. If the temperature increases, the pressure inside of first the kinetic energy of the particles increases, which means the pressure inside of the leaf increases, which means the diffusion gradient increases, which increases the rate of transpiration. So it seems like quite a long process, but it's fairly simple. So just remember the 5 steps. Temperature increases, kinetic energy increases, pressure increases, the diffusion gradient increases, and the rate of transpiration increases. So everything increases. So again, let's look at this on a graph. So you have temperature on the x-axis, rate of transpiration on the y-axis. So this is going to be a very simple linear graph. As temperature increases, the rate of transpiration increases. Okay, so a very simple graph. Go back and look through it step by step if you need to, as there's a few steps involved, but it's quite simple actually. The next factor is light intensity. So the way light intensity affects the plant is it causes the stomata to open and close. So most plants open their stomata during the day and close their stomata during night. This is because the plants don't actually want to lose too much water. So it only opens the stomata when it needs to. And that is during the day when photosynthesis takes place. So it can take in carbon dioxide and let go of oxygen. So the water can only escape when the stomata is open during the day. So light intensity is going to have a major effect on the rate of transpiration. So as the sun comes up and the light intensity increases, the stomata opens wider. And when the stomata is wider, it allows more water to escape at a certain point. But then as the sun goes down again, the stomata is going to close and less water will be able to get out. And the diffusion gradient is going to decrease again. So let's quickly look at the graph for that. So very similar to with wind speed, the initial increase is going to be very sharp. So as light intensity increases, the rate of transpiration will increase dramatically. But then it will start to slow down. And eventually it is going to plateau and not increase at all anymore. This is because the stomata can only open so much and then it can't open anymore. So above a certain point of light intensity, there's going to be no effect on the rate of transpiration. Okay, but this graph is actually not one in your books. It is just I wanted to show you how it looks like so you understand. Important for you to know is that as light intensity increases, the rate of transpiration increases. Then lastly, we're going to look at altitude. So altitude is the height above sea level. So if you know something about altitude, then you know that the pressure decreases the higher you go above sea level. So if you've ever been to Gauteng or Limpopo or the Drakensberg mountains, then you would have experienced that the air feels different. It's kind of difficult to breathe sometimes, especially if you're doing exercise. And that is because the pressure decreases. So what does this mean for plants? Well, as discussed earlier, plants have an internal pressure, but that internal pressure works against the pressure on the outside, the atmospheric pressure. And this atmospheric pressure is around about 101.3 kilopascal, if I remember correctly. But the higher you go above sea level, this pressure decreases. And as this pressure decreases, the diffusion gradient increases, which means more water will escape out of the plant. Okay, so again, this is not, we're not going to go into depth with this one, but as the altitude increases, the rate of transpiration increases. So if we look at it on a graph, it's not as pronounced as the other effects, so it's going to be a lot smaller difference. But you can see here, as the altitude increases, the rate of transpiration increases slightly. Okay, so here's a table just summarizing all of the effects. Just remember what happens for each of these effects. So as the wind speed increases, rate of transpiration increases. So you must know that for all of them. This is just a summary. You need to know the other details as well, but this is just a nice summary for you to remember. Next, we're going to look at adaptations of plants to reduce water loss. So plants are adapted to their environments, but not all plants have the same adaptations because not all plants are in the same environments. So plants that live in very harsh environments need to have adaptations to help them reduce water loss. So plants in arid or desert conditions, they have special adaptations to not lose too much water, and we're going to look at those now. So the first adaptation that most plants have is they have smaller leaves. So this is quite simple. They would increase the thickness of the leaves and reduce the surface area of the leaves so that there's less area to lose water. And examples of this is succulent plants. If you have a look at their leaves, you would see that the leaves are very thick and smaller, so their biomass is actually a lot higher than the size of the plant would suggest. So they still have a lot of mass, but not a lot of surface area to lose water through. Okay. Next, the next adaptation of the plant is epidermal hairs. So I couldn't do this with animation, so I'm just going to draw them in. So on the epidermis layer, they would have little hairs on the leaf, especially on the underside of the leaf. So if you've ever seen um, or you've ever taken a leaf and you felt that it's a bit fluffy on the underside of the leaf, then that would be the epidermal hairs. And the reason for this is as the water escapes out of the plant through diffusion or evaporation, it gets stuck in these hairs, or they stay around the leaf because of these hairs. So this causes a reduction in the diffusion, or it reduces the diffusion gradient, because the immediate environment outside of the leaf has a higher concentration of water. So this reduces the diffusion gradient. Okay, so this is the next adaptation, epidermal hairs. Then the cuticle, you should know pretty well by now. Most plants have a cuticle, especially on the upper surface of the leaves and the stem, and this is to reduce water loss. But sometimes that cuticle is not enough, so even the cuticle can be improved. So some plants have a thicker cuticle, and they also have a shiny cuticle, because if the shinier the cuticle, the more of the sun's infrared radiation will be reflected, and that reduces the temperature inside of the leaf, which reduces the rate of transpiration. So two adaptations of the cuticle is a thicker cuticle and a shinier cuticle. Next, we're going to look at adaptations of the stomata. So the first thing you will notice here is that the picture is turned upside down. That is because most plants have their stomata on the underside of their leaves. And this is more prevalent in plants that need to conserve some water. So they would have the majority of their stomata on the underside of the leaf, and that is because the top of the leaf is directly exposed to the sunlight, meaning higher temperatures and higher light intensity. So if it's on the underside of the leaf, there's lower temperatures and lower light intensity, decreasing the rate of transpiration. The next factor, or the next adaptation that some plants have, is they actually close their stomata during the warmest period of the day. So most plants open their stomata during the warmest period of the day, because that is when they get the most sunlight, so that they can produce the most food through photosynthesis. So they need to open during the hottest part of the day. But plants in the desert, or some plants in the desert, are adapted to close during that time. So they have a bit of a different way of functioning, and there's a lot of interesting biochemistry involved there that we're not going to get into, but this is an adaptation of some plants to close their stomata during the hottest part of the day. And then lastly, or second to last, some plants just reduce the amount of stomata they have. So they just close, or just not have they just have less stomata on the surface of the leaves. So that is one way of reducing the rate of transpiration. It's just having less stomata. And then the last one we're going to look at is sunken stomata. So a sunken stomata is, as the name suggests, just a stomata that is a bit indented. So the stomata sits a bit deeper in the leaf. And this creates a cavity where water will collect, which will reduce the diffusion gradient and reduce the rate of transpiration. So usually this sunken stomata will also have epidermal hairs, and this is then going to trap that water that evaporates in this cavity, which will then reduce the diffusion gradient, reducing the rate of transpiration. Okay, and that is it for the adaptations and of the notes that we are going to, or the notes that I chose to discuss in this video. So I really focused on the things that is important to understand. There's a lot of other notes that you have to write down and that you have to know, but that is more knowledge that you can, that you have to study. So the things I discussed here is the things that requires you to understand what's going on. And if you understand it, it's a lot easier to remember it. So I hope the video helped, and I hope it wasn't too long for your liking. I tried to go through it as quickly as possible. So yes, good luck with the work. Good luck with the rest of the lockdown, and I hope to see you guys soon.